What is LNG? What is condensation temperature of LNG? Well, LNG, you know that probably already, it's a cryogenic natural gas condensed to liquid at atmospheric pressure. So the condensation, just liquefaction point, is minus 162 degrees Celsius per IGC code and SIC to LNG basics. When liquid transformed to gas, it expands to 600 times by volume. Yeah? So that's why we need to condense it and store as liquid for easier transportation. So what is reference temperature of LNG? This question was recently asked to a second mate on my vessel, an LNG ship, by Sire Inspector. So he wanted exactly two definitions. Don't ask me why these two definitions. So she told him one, and I added from myself the second one. So basics, yeah. Without vapor, pressure and temperature control. It's one condition. So the temperature corresponding to the cargo vapor pressure at pressure relief valve settings, maximum allowable relief valve settings, yeah, MARVs. And second definition, with vapor and pressure temperature control, it's the highest temperature the cargo may reach at termination of loading or unloading operations or during transportation. So this is what he wanted to hear. So just remember it. There is no chance you're gonna be asked it, but eventually, someday, one Sire Inspector may be approached to you with this question. Next one. What is the difference between natural boil of gas and forced boil of gas? Well, natural forms naturally due to ambient heat ingress into cargo tanks. It's like swell, heat, yeah, also rough sea. All of these are impacting and affecting of natural boil-off. Forced boil-off is produced intentionally by vaporizers for fuel or pressure control. So in case you're in ballast, you have minimum LNG remaining only for cooling your tanks and for the sea passage. Of course, the boil-off, the gas, is not enough for your engines, and you have to run only on gas, according to charterer, yeah, for instance. And what you have to do? If you don't produce forced boil-off, your tanks will start, you will start sucking more and more, and tanks will be, becomes vacuum. So this eventually, by the low pressure, you will have ESD. So that's why you need to take the liquid, warm it up with steam or glycol, and then you will have on the entrance to your engines pure gas, yeah, with plus 20 degrees Celsius. So that's the main point. What is the difference between forcing vaporizer, LNG vaporizer, and high pressure vaporizer? Let's see. Forcing vaporizer is supplied with LNG liquid from cargo tank by fuel or spray pump with 2.2 and around 5 bars. It makes forcing vaporization of LNG by heating it with steam or glycol, as I said already, mixture. Basically, it's like a heat exchanger, yeah, LNG passing one side, and then you have the tubes with the glycol or steam. It's like this tube heat exchanger. It's nothing special there. Designed to carry such temperatures, of course. Then forced boil-off would be supplied to your LD compressors, yeah, low duty or fuel gas compressors, doesn't matter, the definitions can vary, with 0.2 bars, like 200 millibars. And the flow rate here, just remember it. Look, you can see the difference already, yeah. The LNG vaporizer is supplied with LNG liquid, same way. And it has like few modes. Unloading mode with closed vapor manifold to save cargo tank's integrity. This is just a reference temperature minus 140. Or in gassing up mode when LNG supplied from shore, for instance, and you need to spray it and produce vapor. So it starts from plus 20 and then it could be gradually cooled down. So that's why you need such a big capacity. Look, capacity here is much bigger than this one, yeah? So the only difference is bigger capacity for another procedures. And the king of pressure, high pressure vaporizer. high VAR call them. You will meet those on MAGI vessels, vessels with MAGI engines, supplied with LNG liquid from cargo tank by fuel spray pump, same way, 4 to 6 bars. Then this liquid goes to high pressure pumps and enters vaporizers with 300, 315 bars, sometimes even more. If it's, let's say, a ton carrier, very large a ton carrier, they can give up to 380 bars. So it makes forcing vaporization of LNG by heating it with glycol mixture and leaves vaporizer with 300 bars. So then this 300 bars goes to your engines directly, to MAGI engines. And you can see the flow here is not so, flow rate is not so big. Yeah. It also could be combined operation for these engines. Yeah, for the MAGI engines, you can combine operations with fuel gas compressor or LD compressor plus high pressure vaporizers. Dedicated mode, it's called. High VAR exclusively supplies only MAGI engines with this. Yeah, through this principle that I explained to you. Yeah, from 300 bars goes directly there. And our LD or fuel gas compressors feeding only dual fuel generator engines after second stage with 5 and 6 bars, Helloco Belco compressors. Could be also Burkhardt, it depends on the maker. And the parallel mode. So in parallel mode, high VAR and LD compressors simultaneously feed MAGI with 300 bars of gas, and also compressor can supply our generators with 5 and 6 bars, yeah, after second stage. So this is how it works. Dedicated mode, parallel mode. And next question, what is heating media for vaporizers? What was used before and what is now? Before, steam was in use as a heating media, and in the latest application it's glycol. What is glycol? Basically it's the same antifreeze solution you're using for your car. It's just a bit different calculation and of course different proportions. So it's the same as antifreeze. Due to better temperature control, safety and system efficiency, it was changed to glycol. Unlike steam, glycol water mixtures can be operated at lower temperatures, reducing the risk of overpressure and steam leaks. By the way, one vessel, there was a huge crack of inside these tubes of LNG vaporizer, and the valve was open, so this steam was going to vapor header. And of course it was accumulated into, there was plenty of moisture, it was frozen, and there was a lot of water as well there. So when the guys open, and I don't know how many tons of water they just drained. And of course that crack is not easy to fix. It was huge claim. So, you know, if steam leaks, you won't notice it very easily. But if glycol leaks, then glycol in your tank will gradually decrease the level and you will have alarm. You can also see it, you know, day by day measurements. So that's why glycol is now mostly in use. Glycol systems also prevent freezing at low temperatures, making them ideal for cold climate operations. Additionally, glycol provides more stable and uniform heat transfer, blah blah blah. So that's why glycol. Then, why are we heating cofferdams? What is heating media? Which temperature maintain? What is cofferdams? Let's say you have your cargo tank, yeah? Then it goes primary barrier, then it goes secondary barrier, yeah? And then it goes cofferdam. So you have cargo tank, barriers, cofferdams, again, barriers, cargo tanks, barriers, cofferdams. So in between two cargo tanks, between their barriers, there are cofferdams, and we have to warm them up to heat them. This question was for one gas engineer as well, recently on the interview. To avoid condensation inside the cofferdams, it will be plenty of moisture because of differences in temperature. It can also be seen actually in the duct keel, yeah, under the cargo tanks. You can see how moisture is there. because of this. There is no actual heating there, so it's kind of visible. Glycol is used for heating up to the cofferdam, so we are maintaining, okay, it's +7 from up to +7 to +14. It depends on the project of your vessel.